Hello everybody. I would like to talk about the morphing tessellation that you can do using tissue, and in order to see how it works we will use the latest version of tissue that is not the one that is for the moment shipped with Blender 2.80. I did some update in the code, so if you go to my GitHub page you will see that for Blender 2.80 the latest release is the version 0330. So from here you can download it. If probably I mean if you want to use the latest version, just check my GitHub and you will see which is the latest version that I've developed. So for the moment we will use this version, and in this case we have a base object that is this geometry, this abstract geometry here, and we have a component that is this simple object that we can see here. In the base geometry I'm using some modifiers, in particular subdivision surface, because I want to do a patch tessellation. Patch tessellation means that instead of using just the flat faces that normally you have in a mesh, I would like to use the faces that are smooth using a subdivision surface. So basically the patches that you see when you have a subdivision surface and optimal display on. So if you just use the modifier, you will see just a smaller component following the subdivision of the faces. But if you see this optimal display, that means that you can also use the bigger patch that follow the curvature but have the same size of the original faces. So this is why I developed the patch option for the tessellation. So in this case, if we just see what happens if you do a tessellation, normal tessellation, just press OK and see what happened. You will see this where each component is applied to the flat faces. If we want to take advantage of a small curvature that we have, we need to use the patch tessellation. Patch. Okay. Maybe it was already patch. Oh yes, this is squad that use the geometry without modifier. The patch use the geometry out of the modifier but keeping the sides of the faces before the last subdivision surface. I have only one subdivision surface, so this is the only one that we take into consideration. So let's move this object here and just make it a little bit thinner, 0.5. Okay, perfect. Okay, so now let's assume that we want to change the shape of a component along this geometry, so that we don't want to keep the component with the same shape in every part of the object. First thing that we need to do, let me just hide the wireframe in this case. Okay, so the first thing that we need to do is to create a vertex group in the original mesh, because this vertex group will inform the gradient, according to a gradient, how this component will morph along the surface. In order to create a vertex group, you can just go to weight paint and start painting on our geometry, or maybe selecting the correct one, this one, weight paint, and we can start painting this object. Basically, when you paint using weight paint, you add information to each vertex. Those information are called vertex groups, and each vertex can contain a value that goes from 0, that is the blue, to 1, that is the red. You can paint it manually. You can select some vertices and press assign to the vertex group, defining before which is the weight value that you want to assign manually. For instance, I assign 1 here and I want to assign 0.5 here. If I go to weight paint, you will see that now here is red and here is green. But there are also other ways that you can use in order to assign those vertex groups. For example, you can use the vertex weight proximity, that is a modifier that allows to define the vertex group according to an object, according to the proximity of an external object. Or, for instance, we can use some tools that I have created in tissue. For example, you can create a vertex group according to a mathematical formula. So you can use weight formula, and there are some variables that you can use. For instance, you can use the local coordinates that goes from 0 to 1. So in this case, let's say that we want to create a gradient that goes from the bottom to the top. We can use RZ, that is the relative Z. According to how big is the object, is automatically remapped from 0 to 1. So if we just press OK, you see now that we have this gradient that describes the change in the Z. You can create, of course, more complex formulas. For instance, you can check those examples. So you can create harmonic variation, and if you use some variables that are I1 that are integer slider, or F1, F2, F3 that are floating slider, you can add some interaction here, so you can change manually the parameter in order to see how they change. In this case, the subdivision of a mesh is not that high, so you will not see much detail in the vertex group, because the vertex group is assigned to the original mesh, not the result of a subdivision surface. So in this case, just keep it simple. So let's use the formula RZ that we have created before, and this will be fine for this example. So we created a vertex group. In this case, I want to rename my vertex group, because the name will be relevant at some point, and we can call it just A. Okay, now we have a vertex group, so when we do a tessellation, you can use some advanced settings. In particular, you can use map vertex group. If you use this option and you go to weight paint, you will see that now in the tessellated object you will have the same vertex group that you had before in the original mesh. Okay, so in this way we can keep this layer of information. Now what we need to do is to create a morphing effect of our component. How can we morph an object inside Blender? Well, we can use shape keys that are usually used for animating simple things that doesn't require a proper rigging system. So when you create a first shape key, it will create the basis, that is the object as you see in that moment. So usually is the default object without any deformation. And then you can create a new shape key, and in this shape key you can add some modification. You can change a little bit the shape. The important thing is that shape keys doesn't add new vertices, doesn't delete vertices, doesn't add faces. They just keep different coordinates of existing vertices. So if you start to extrude or delete some parts when you have the shape keys, you can see sometimes some weird result. In this case, if we go to edit mode, now we are editing the key one. So for instance, we can select this loop of faces here, and we scale it down, making this element more close. Okay, if I return to object mode, you will see that the object is still the same. But now you see that in this key 1 we can change the value using this slider, and changing this value you will see that the object will morph in the new version of itself. You can disable them, or you can just change those values. Okay, now let's keep the value to 0, and if I go here to my object and I activate the option that is use shape keys. Okay, now you will see that you have the same shape key here. This shape key can change value, so you see that this is the closest version, this is open. And also, using the shape keys in Blender, you can combine them with vertex group. So let's say, for example, that we want to use this vertex group here. In this case, you see how these components change along the Z according to a vertex group. Okay, but if you want to create, for example, more effect, if you want to have more groups, and if you want to combine them automatically without changing the parameter manually here, you can create, let's create, for example, a new vertex group here. Maybe maybe we can use a gradient along the x, Rx. Okay, great. and we can call this group close, and we can call this other group, let's say that we want to combine with an increase of thickness of the component, or maybe we can change the green part. Maybe we can call it thickness. Okay, so we will use these two vertex groups in order to change two different behavior of our component. Let's return to our component. Let's create a new group, and in this case, in this group, I want to scale along the x of 2 point, no, maybe more. Let's go to the top view as s y. Let's say 4. Great. And also here s x 4. Okay. I want to change also those I want to scale in the plane x and y, so I can press S and Shift Z, and we can use a value 120. Okay, let's say like this. Wait, something, because it's individual origin, sorry. Median point, S Shift Z, okay, now makes sense. And 2.3, okay, good. So now we have one vertex group that is changing the top part, and another vertex group that is changing the bottom part. Okay. Now I want to give to those groups, to those shape keys, the same name that we use to the vertex group. So this one is open, is close, right? Yes, close and thickness. And this one is thickness. Okay. Now, if we refresh the tessellated object, okay, you don't see the morphing, but you now see that close and thickness are automatically associated with the two equivalent vertex group. So that means that if we increase the value here, it automatically uses the vertex group. The same here. But if you want to keep the same value by default without changing manually each time, you can just set the value that you want in the original component. So let's say, for example, that you want value 1 and 1. So you want to see both maximum values in the tessellated object. Now you can just refresh, and now automatically have the gradient. If I change it and I refresh, it will automatically use the value that I have in my component. Exactly like that. Now we can, you already have merge. Now when you use merge in this new version, you can also close automatically the mesh. For instance, in this case I have a component that have openings on all the sides, and those openings remains also in the tessellated object. In this case I want to cap them, so it is actually simple to do. You can just go to edit mode. By default you should see all the non-manifold edge selected, and you can just press F. But this is something that you have to do manually each time, so I say, okay, why not adding an option for that? So in close mesh you can just choose cap holes, and this will automatically do this operation for you. Okay, now we can add a subdivision surface, and we can see how it looks. Okay, so you see now both variation in the bottom part and in the top part according to the vertex group. The nice thing of working with vertex group is that you can actually change them manually at some point. So let's hide the subdivision surface in order to make it more fast. But if you go to weight paint now, and for example you select one of the two vertex group, let's say that we want to select close, you can manually change the vertex group in the weight paint. You just need to be careful because sometimes you see that you cannot paint perfectly. You need maybe to smooth the weight sometime. So because it's more difficult to paint a three-dimensional geometry like this with a three-dimensional component along the surface, I suggest you to do this operation on a flat surface, as you can see here, and this will make more easy to control the gradients and everything in the final one. So if I now refresh my tessellated object, we'll reload again the original vertex group, deleting all the changes that I did manually. Okay. So basically you can create any number of shape keys and make them matching the vertex group that you have in the base mesh, and just remember to keep the same name and also to set the value that you want to see in the component. So remember that if you don't see the morphing effect, probably the value is 0 as it is by default. In this way you can for example use different values. Let's say that you don't want to see the component that close, maybe you want to keep them a little bit open, so you can just change here and refresh here and you will see the same value in the tessellation. You see, same value. Okay, I hope that this was clear. If you have questions, please add in the comment, and any feedback is appreciated. Enjoy!